Okay guys, today we're going to do our last unit, Unit 5, Exponents and Radicals. So starting with a radical is a square root. To simplify a radical expression, first you're going to factor any numbers that are underneath the radical expression. You're going to next expand variables that have exponents. With exponents. And then last, you're going to circle pairs. The good thing about simplifying radical expressions is that the calculator will give you the prime factorization of any number. So it's not going to help you much with the letters, but at least it'll get you the prime factors of the number, and the shortcut for that is menu 23. Okay, so I have 4 examples right underneath. So starting with 432, I want to simplify this. So I'm going to go to my calculator, and I'm going to go to menu 23 and type in the number 432. Okay, so what it gives me when I do that is, so I'm still going to draw the radical symbol, 2 to the 4th power times 3 to the 3rd power. But anytime you have exponents, you want to expand all of that out. So you see how the 2 has the 4th power? That means that the 2 is going to be there 4 times. And then since that 3 has the 3rd power, that 3 is going to be there 3 times. Okay, then our last step is to circle any of the pairs. So I have a pair of 2s, another pair of 2s, a pair of 3s. That 1 3 that's by itself, it's not a pair, so that means it's going to stay inside of the radical. So anything that got circled, you're going to multiply. So I have 2 times 2 times 3, which gives me 12. And on the inside, that 3 needs to stay there. This is the answer. Okay, let's go to right next to it. So I have 3 square roots of 96. It's still the same way, only you're going to have to leave that 3 on the outside until the very end. So I'm going to go to my calculator, do menu 23, type in my 96. Okay, so I have my 3 on the outside, but on the inside, I have 2 to the 5th power, which means I need 5 2s and 1 3. Then I'm going to circle my pairs. So here's a pair, here's a pair. Now the 2 and the 3, that's a 2 by itself and that's a 3 by itself, so it's going to need to stay inside. So on the outside, I still have the 3 that was already there, but now I have a 2 from this circle and another 2 from that circle. On the inside, I have the 2 and the 3 that were alone. So now we're going to multiply everything. 3 times 2 is 6, times 2 is 12. And on the inside, 2 times 3 is 6. Okay, the bottom 2 examples are radical expressions that have letters in it, but it's still the same way. I'm going to find the factors of 12, which gives me 2 times 2 times 3. Now the variables, I want to expand them out. Since it's x to the 3rd power, that means that there's 3 x's. And since it's y to the 2nd power, that means that there's 2 y's. Now we're going to go and circle the pairs. So I have a pair of 2's. That 3 is by itself. I have a pair of x's. That x is by itself. And then I have a pair of y's. Anything that got circled can go to the outside. So 2x, y. Anything that wasn't circled stays on the inside. So 3x. Okay, and one more example. 52 m to the 4th power p to the 3rd power. Do menu 2, 3, type in 52 to get the factors, and I get 2 times 2 times 13. And now for the letters, m to the 4th power means that m is going to be there 4 times. P to the 3rd power means p is there 3 times. Now I'm going to circle the pairs. So there's a pair of 2's, that 13 is by itself, a pair of m's, another pair of m's, pair of p's, and then one p by itself. Anything that got circled is going to go to the outside. So 2, m, another m, and a p. On the inside, anything that was alone, so the 13p. But see on the outside how I have 2 m's? That means that they can go together. So instead of writing 2 m's, I'm going to put m to the 2nd power. And this would be my final answer. Okay, so that's what we get for our radicals. If you open up your booklet, the next thing that was on this unit was exponents. There's a bunch of different rules when we're doing exponents. I wrote them here. But with these, you don't have to worry too much because they will be on your star formula chart. You don't have to memorize the rules, but you do need to know how to use them. One warning, though, is that on here I was nice and I gave you every single rule. But on the star chart, this one and this one are not listed. So that one you need to know. Okay, so let's start looking at our examples. I have a squared b times a to the 3rd power b to the 7th power. Since they're next to each other in parentheses like that, I know what they want us to do is to multiply those letters. So I'm going to go up to my chart here. It's the product property. When I'm multiplying letters, I add their exponents. So starting with the a's, so the a's here, I'm going to combine them by doing a to the 2 plus 3. And then the same thing with the b's. I have b. This first one doesn't have an exponent, so there's an invisible 1 there. So 1 plus 7. And then now actually do this math, so that would be a to the 5th power, b to the 8th power. Okay, right next to it, this time we are dividing. So this is called the quotient property. So if I look here, the quotient property tells me that when I'm dividing, I subtract the exponents. So for D, I will have 2 minus 4. For E, I will have 6 minus 3. And for F, I will have 2 minus 1. So now that I do this, it would give me D to the negative 2, E to the 3, and then F to the 1, but I'm not going to write the 1. So we're still not done yet because I have a negative exponent. That negative exponent, there is a rule for that. Whenever I have a negative exponent, I move it down to the bottom of the fraction and it turns positive. So here what I'm going to do is, since E and F are both positive, they get to stay on the top. But since D was negative, it goes to the bottom. That would be our final answer. Our third example, we have 2 letters that already have exponents, but then they're in parentheses raised up to another exponent. This is called power to a power. So what it tells us to do when that happens is you multiply those two numbers. But it has to go to everything that's in the parentheses. So that 2 needs to go to this 4. So it'd be x to the 4 times 2. And then it needs to go to the y. So y to the negative 3 times 2. When I do this math, it would give me x to the 8, y to the negative 6. And then just like before, because I have that negative exponent, I'm going to need to move that to the bottom. So this would really turn into x to the 8th power over y to the 6th power. Okay, next to that, this one, it has the dots to mean multiplying, but I have 3 terms. Honestly, it's still pretty simple. When you're multiplying letters, you just have to add the exponents. So starting with the m's, I have 2 plus 5 plus negative 1. So that's 2 plus 5 plus negative 1. Then with the p's, I have negative 2 plus 6 plus 1. That one doesn't have an exponent, but it's invisible 1. Okay, so doing this math, I would get m to the 6, p to the 5th. So just because it's longer, don't let it confuse you. It's still the same rule. Okay, let's go to the other side. Here's some word problems. It says the length of a rectangle is 3x squared y to the 9th. The width is 7x to the 3rd y squared. What is the area? So hopefully we all remember that area of a rectangle is length times width. So all I need to do is multiply these two expressions. I would have 3x squared y to the 9th times 7x to the 3rd y squared. So this is basically like the one that we just finished doing. I'm going to start by multiplying the first numbers. 3 times 7 is 21. Next, I'm going to go to the x's. So x to the 2nd power times x to the 3rd power. When we multiply letters, we add their exponent. So 2 plus 3 is 5. And then last, the y's. So y to the 9th times y to the 2nd power would be y to the 11th power. Right next to it, a rectangle with an area of 24p to the 10q5 has a width of 6p3q3. What is the length? So this time they gave you the area. So if they already give you the area, this time you're going to divide, and area always goes on top. Okay, so let's start our dividing. So starting with the regular numbers, what is 24 divided by 6? That gives us 4. Next, we'll go with the p. So p to the 10 divided by p to the 3rd power. When we're dividing, we subtract. 10 minus 3 gives us 7. And then last, those q's. So q to the 5th power divided by q to the 3rd power. When we divide, we subtract exponents. So it would give us q to the 2nd power. Okay, and the last two examples, it's all exponent rules combined. So it wasn't just one little easy piece. These are multiple pieces. This one here on the left was an actual question that showed up on the STAR last year. And I believe I gave this question to you on the test before. So when we have something like this, what I would suggest is doing everything on the top first. So starting here on the left, I have this exponent that needs to go to both things that are inside the parentheses. So when I write it, I still have the 4, but now I have x to the 4th power, y to the 6th power, because when you put it in like that, you multiply. So over y to the 4th. Everything else I'm going to just rewrite so I don't get confused. Okay, so now going across the top, I'm going to multiply. So I still have the 4, but now I'm going to combine letters. I have x to the 4th power times x to the 2nd power. When we multiply, we add the exponent, so that would give me x to the 6th. Okay, and then the next letter, I have y to the 6th power times y to the 8th power. So again, when you're multiplying, you add the exponent, so that would give me y to the 14th power. Okay, now let's do the bottom. If you look at the bottom, everything is different. So I do have 2, x to the 3rd power, y to the 4th. The only thing that I did is I rearranged everything so it could be in alphabetical order. But from here, now it's a simple division problem. So let's start with our coefficients. 4 divided by 2 gives us 2. Then the next letter, x to the 6th power divided by x to the 3rd power. When you divide letters, you subtract their exponent. So 6 minus 3 is 3. And then last with the y's. Y to the 14th divided by y to the 4th. I'm going to subtract their exponents. And I know that 14 minus 4 is 10. So there is our final answer. So this one took us about 3 steps to do. So these, even though they look complicated, they're not too bad as long as you go step by step. Don't get overwhelmed. Okay, and then last example right next to it. So when we do order of operations, this exponent always gets to be distributed first. That's the first thing that we have to do. So right now, I'm going to start by just rewriting the first one. But on the second one, I'm going to distribute that 2. So it would become a to the negative 10, because negative 5 times 2, and b to the 4th. Okay, but now from here, I could do each letter separately. So a to the 3rd power times a to the negative 10. When you are multiplying letters, you add their exponents. 3 plus negative 10 would give me negative 7. And the other letter, b, I have b to the negative 4 times b to the 4th. When you multiply letters, you add their exponents. Negative 4 plus 4 gives me 0. So let's take a look at our answer. First of all, we have a negative exponent, so we're going to have to fix that. And second of all, we have something that's to the 0 power. So I'm going to go back to our rules up here for a second. It's the very first one at the top. Anything to the 0 power is going to give you 1. So over here, I could just rewrite this as a to the negative 7 times 1. And since it's times 1, we don't need to write that. But then again, it's still negative. I have to fix that. So we're going to turn this to a to the 7th at the bottom. But right now the top seems empty, so you're going to fill it in with a 1. This would be our final answer. Okay, so this is all for our review for Unit 5. You guys have an assignment that has 5 multiple choice questions on it. Make sure you work on that here in class. All 5 of these white papers will be due on Monday.